Thank you everyone for joining us for this webinar, Speaker Cable and Power Cable Basics, Connections, Cable, and Repair, presented by Fedj, Jeff Sylvanus. My name is Laura Lawrence, and I'm the Global Marketing Director at Harman. So just a few things before we get started. Everyone on the call is muted to keep down noise levels during the webinar. However, there is a Q&A function where you can submit questions to the presenter, and he'll try to answer as many questions as possible at the end. This webinar is being recorded, and the link will be made available a few days after the presentation. We do have a number of other webinars taking place over the next few months for audio, lighting, video, and control, and we'd like to encourage you to take a look at the different webinars in our Learning Sessions workshop series on pro.harman.com. We're adding new sessions daily, and right now we have over 20 sessions scheduled for September and October, so watch for those on the calendar. And now I'd like to introduce you to Fedj, the presenter for today's webinar. Currently the Chief Repair and Fabrication Technician at Rat Sound, Fedj has over 40 years experience as a front of house and monitor engineer, tour and production manager, technician, and electrician for artists including Akon, Aretha Franklin, Patti LaBelle, Toto, Primus, Fishbone, and Red Hot Chili Peppers. And now I'll pass it over to you, Fedj.
Thank you, Laura. Hi, everybody. My name is Fedj. That's Jeff backwards. It's an old nickname, and it's stuck. I've been working live productions since the ripe old age of 9 years old. I got into music by the time I was 20 years old and just never looked back. Started in a little theater and picked up little tidbits along the way. But it was rock and roll on the live stage that really taught me the most of my knowledge base. Today I wanted to go through, I wanted to thank Harman for putting all of this together, and JBL Professional. With COVID out there right now, a lot of us are hurting for work, so it's great to be able to encourage all of those out there to participate any way, shape, or form that they can. And in that, I wanted to add my 2 cents. There's a lot of instructions for the upper end of things as far as production, recording, lighting, all of that stuff. But I wanted to make sure that we touched base on the basics. The first webinar I did was on just mic cables. But for this one, I wanted to touch base on speaker cables and power cables. This is a basic necessity for the understanding that comes along with everything else. Now, we're not going to be talking about impedance or loads or amperage or any of that. We're basically focusing on the connectors and the cable themselves. There's some tips I've learned over the years that make things a lot easier. We're going to be dealing with, today, we're going to be dealing with the NL4, the NL8, which are both common speaker connections, commonly referred to as speak-ons. But the technical specification from Neutrix, who makes them, is the NL4 and the NL8. I'm going to start with the NL4. Actually, let's start with a new one, and then we'll get into troubleshooting and repair work after that. Commonly, we are using an NL4 for a speaker connection that's requiring two sources. Generally, you'll find this in a two-way box with a low and a high, whether that's a monitor or a studio monitor, a wedge monitor on stage. Or a front of house PA box, a two-way box. It's something that's requiring a low and a high is generally what we're going to use the NL4 to connect. You'd have to check with the manufacturer of the speaker component and make sure that that jives with your amplification and processing to know if the low low is coming first and the high is second, or vice versa. But that is something to research as you get to the work that you're going to do. The basic thing that we want to talk about right now is actually making the connection. So I'm going to use a brand new NL4 FC. Now, the thing that's so funny about this is for all the years I've been working with them, I always thought that the connector that we're putting on the end of the cable to plug into the speaker is a male because it goes into a socket. But actually, this is the female, hence the F in the model number, NL4FC. The male, which is the receptacle, which is what you'd find on the back of the speaker. Actually, let's do the little camera over here. That is actually the male. So it was news to me to find out that when ordering a bunch of parts, I had ordered the wrong part because I was ordering what I thought were male, and lo and behold, found out they were all female. So be aware of that. Now, in the package, you will have the main guts. Let's go to the zoom again. This will have the terminal block and the connections that go into the speaker or the panel. The strain relief, there are two of them. There's a black one and a white one. The case, which goes over the entire assembly when you're finished. And of course, the main key ingredient, which is the first thing that we need to think about when putting on a new connector, the boot or the cap. Before you start anything, you want to make sure, take the boot and put it on the wire that you're going to be working on. So many times, and some of us with the longest track record in the world will go ahead and make our full connection only to find out, oops, I forgot to put the boot on the wire first, and now I have to take off everything that I'd already worked on just to put the boot back on so I can close the whole thing up. Anyway, I'm going to trim off the end so it's a nice, flat, even, all the wires at the same length. And you got to consider with these connectors, you're going to have the wire protruding into the terminal, and you're going to have the strain relief after that. In the strain relief on the inside, you'll notice that there are little ridges. If you hold it up to the side, you'll be able to see them. A little hard to get an angle where you can actually see them in this shot. But these ridges go about that far in, and those grip the outside jacket. It's important that you know where that is. It's about 3/4 or 7/8 of an inch away from the end of where you've cut the jacket. The reason that's important is I want to make sure that this strain relief, this cable grip, is actually gripping the outside of the cable. If you've stripped too far back, then all that's going to be inside of the cable grip are the individual wires, and the strain relief, the cable grip won't do anything. So you need to make sure that you're keeping within that 3/4 of an inch to say 7/8 of an inch length when you're ready to strip it. So with that said, let's go ahead and strip off the outside jacket to expose the 4 wires inside. And there's a multitude of ways of stripping the jacket off. I really prefer these electrician scissors that you can get at any Home Depot or any hardware store. They just make fast work of the job, and you don't, and as long as you're careful, you're not going to cut into the individual leads. You're not going to cut into the insulation of the individual leads. This particular cable, The color choices are black, white, orange, and yellow. Now, depending on the shop that you might be working with, or the company you might be working with, or the product you might be working with, those colors can vary. At RAT, we follow the edict of the Whirlwind color code. You can go online and download what they've got for individual wiring color codes. And it seems to be an industry standard. And it relates basically to the wire and the wire colors that they have. However, this is not a Whirlwind cable. So instead of red and green, we have orange and yellow. We have decided at the shop that we want to make black and white the number 1 connector, plus and minus, or the first speaker. And the second speaker connection is going to be orange and yellow. Black will be the hot. White will be the minus of number 1. Orange will be the hot of number 2, and yellow will be the minus of number 2. The reason that we think of it in those terms is the labeling on the connector itself. It's very hard to see, but Neutrix was nice enough to label in embossed letters on the back of the connector, 1 plus, 1 minus, 2 plus, 2 minus as you go around the individual terminals. But it's really hard to see. So here's something to keep in mind, and it's a neat little trick. After making many of these, it's come to my attention that this is a faster and simpler way to find number 1. If you'll notice, there are 2 little dimples on the end of the connector. There's a fat one and a narrow one, and that coincides with the 2 grooves on the receptacle. There's a fat one on the top and a narrow one on the bottom. The fat one, the terminal just above that, is number 1 plus. So let's get this into a better lighting angle. There we go. So there's the fat dimple, and just above that is going to be number 1 plus. The terminals, as you can see, have a little Phillips screw on each of them. There's 2 on this side, and then 2 on the opposite side facing the opposite direction. The 2 that are facing you, going the same direction, is going to be 1 plus, as we said, near the fat groove, or the fat dimple, and next to that, 1 minus. So rather than having to find the right lighting angle to see those embossed numbers, just remember the fat part is number 1. Narrow part, number 2, right in line with it. Okay. So I'm getting director's notes in my ear as we're doing this. So at any rate, I've got number 1 plus, minus. On the opposite side, I've got number 2 plus and minus. Now we've stripped off the wires and everything, or we stripped off the jacket, exposing the wires. Now I want to check after I've done that strip, because if you'll notice, they're just slightly, one is just slightly longer than the other 2. So I want to go back with my nippers and make sure all of these are exactly the same length. And I'll show you why that's important in a little repair job that I've got set aside coming up. Now, because of the configuration, there we go. 1 plus, 1 minus. I want to make sure black, and then white, and then orange, and then yellow. So when I'm looking at this, this way, I'm not in the right order. Right now I have white coming up on the wrong side, so I'm going to manipulate the wires inside of the jacket so that they come up in the right order according to the terminal block. Again, I'm looking for that fat dimple to start with to make a reference for where number one is. So right now I've got black on top, white going off to this side, orange going to the bottom, and yellow going to that side. So if you'll notice the wire the way I've got it, that's all in line with that. The reason I'm setting it up with all four, it is perfectly legitimate and perfectly okay to do each individual terminal and connection all by itself. It just takes a long time to do it. So what I found is the easiest way to do it is prep all the wires in that configuration so that they're lined up in the right order with the terminals. Then when you've stripped off the ends, and I only want to strip off as much as will fit, you go to that tight shot, inside of that terminal. I want to make sure you see that. So it's only about a little more than 1/8 of an inch, or just shy of a 1/4 inch. And that's all the copper I want exposed on each wire. The reason that's important is I want to make sure that the insulation around each individual conductor goes right up to the flush to the edge of the receiving terminal, so that no copper is exposed when I'm finished making the connection. Now, you'll notice when you open up the package and get everything apart, keeping in mind I've already put my boot or my cap on the wire. And I was using the wrong one. Well, actually, let's go ahead and use the same wire, just so I can do the right prep here. We've already made sure that we have the cap on before we even started splicing or stripping the wires off. I'm going to go ahead and with my strippers, I'm going to strip off just enough of that. Expose just enough copper that it'll fit inside of the terminal on each of the four. And you can use a tape measure if you would like to be absolutely accurate. But after all the years of doing this, I can pretty much eyeball it and get where I need to be. But this, of course, is after many years of practice. Anyway, the reason I want to show you this tip is because it'll save you so much time if you're making a lot of these connectors. And at RAT, I found myself several times before an order is ready to go out the door, somebody will realize we're shy about 50 cables. Fedj, can you rack out 50 cables really quick? So I'll have to be in a hurry and make all of them. Now, because I have staggered the wires in the correct position to coincide with the terminals, and I want to make sure I got that right. No, I don't. White and yellow are in the wrong position. So, I did have it in the right one. Okay. Silly me. Okay, black, white, yellow, and orange. Black is number 1 hot. Orange is number 2 hot. I'm going to stagger these and angle them just a little bit. And you'll notice I'll put a little bit of a difference in where the yellow and the white line up in that angle. The reason I'm doing this on an angle is so I can seat number 1 plus, get it right in there. Oh, I forgot a very important step. Brand new connector, fresh out of the package. And you notice the terminal screws are not all the way out. So make sure before you're ready to make that connection, grab a screwdriver and open these up a bit. Otherwise, you'll find it hard to get all the wiring in. There we go. So back to the wire. I've opened up the terminals, backed off the screws a little bit so there's a little more room in each of the terminals to receive the wire. I'm going to change to my closer view glasses so I can make sure of this. Okay, starting with terminal number 1 hot, which is off of the fat paddle, or the fat dimple, I should say. I'm going to start to seat that. The next one I'm going to seat is yellow on the opposite side, which is 2 minus. And I'm just going to stick the very end of it in there. White, which is 1 minus. And finally orange, which is 2 plus. So what I've done is I've seated all 4 connections at once. So all four conductors are in the terminals all at once, rather than doing them one at a time. Once I've got them all seated, I want to make sure that I've got no copper showing. Yeah, give me a second. There we go. I want to make sure that there's no copper sticking out of those terminals. And once I'm convinced that I've done a good job with that, I can go ahead and tighten up all the terminals. And it doesn't really matter where you start or where you finish. Just make sure that you've got the terminals as tight as you can get them by hand. Because as good as the cable grip might be, the tension of these screws on the individual conductor that's seated inside of the terminal will give you a better chance of the longevity of this connection remaining intact. So once I've got that all together, and I check and make sure there's no wire hanging out of any of those connections or any of those terminals, and I do have a little bit of copper strand sticking out of number 2. I'm going to go in with a pair of fine trimmers and just clear that out so that there is no copper exposed whatsoever. There we go. Okay, that looks all tight and nice and wonderful. Then I'm going to go for the strain relief, the cable grip. And this is important. There are 2 different ones that come in the package. The black one is for a heavier gauge cable than the white one. Now, a lot of times you'll find that companies are using 4-conductor power cable rather than speaker cable. That's all fine and good. The copper inside of the power cable is the same as it would be inside of the speaker cable. The only real difference is the power cable, the individual conductors have a heavier insulation jacket. Excuse me for a moment. Because it's handling higher voltage, there's a thicker jacket on the individual conductor. And also the jacket around all 4 is going to be a thicker gauge of insulation, and it becomes a fatter cable. The reason that's important is choosing which strain relief to use. Because I'm using speaker cable, it's a very tight configuration. There's no extra wadding, there's no extra twine, there's no extra anything inside of the wire. So it's a very tight, concise package, so to speak, of cable. So I want to use the white one. I want to use the white strain relief cable grip. Because it has a smaller aperture and it will grip the cable tighter. If I use the black on this and it doesn't clamp all the way down around the insulation, it will cause you troubles later when you're trying to make the connection. And I can try and show you a demonstration of that later. So unless you're working with actual power cable, 4-conductor power cable, to connect to an NL4, use the white connector or the white strain relief cable grip. Last thing I want to check is when I mentioned those ridges inside of the cable grip, I want to make sure that my jacket is going inside of the cable grip far enough for those little ridges to clamp down on the insulation. And it looks good to me there, so I'm going to go ahead and finish off the connection. Going to take the outer casing and slide that on. You'll find that there's a groove inside of the casing. Basically, you can spin the casing around until the groove fits in. You'll notice also on the cable grip itself, the same tab as the connector lines up. And the way to get that thing to line up in the proper position, because Neutrix was nice enough to think about it, is they put an extra little flange on the terminal block, so that the cable grip is always going to be in the right position. Now, if I spin this 180 degrees around, it might look right on that side, but on this side, you'll notice there's nothing sticking into the little grooves that are set up. So you can tell in an instant that you've got this lined up correctly or not. And it'll take some time for you to, play around with it to find the easiest way for you to recognize that. At any rate, so find where everything slips in on the outer connector, the casing. Slide that all the way on. Grab your boot and tighten that all the way up. Now there is a tool that Neutrix makes that grabs the edges of this and tightens it. It gives you more room to tighten. But rather than investing in that, a crescent wrench works just as well. You want to make sure that that's about as tight as you can get it. But keep in mind, out in the field, if you need to open this, you're going to need a wrench to open it up. So if you want to do it just by hand, that's generally tight enough. But if you want to save yourself some wear and tear on your hands, use a crescent wrench. At any rate, with that connector done, I'm ready to go to the other side. Now, as far as those color codes inside of the wire itself, it really depends on the manufacturer, the shop, as to what colors you want to stick to. As I said, at RAT, we use the Whirlwind color codes. But being that this is not Whirlwind cable, we have, instead of red and green, we have orange and yellow. We've just decided that that is going to be, orange is going to be 2+, yellow is going to be 2-, and that's our standard in the shop. It really doesn't matter, though, what those color codes are, as long as the other end of this mimics exactly what you've just done on this side. So on the other end of my cable, I'm going to need to make sure that I follow the same wiring diagram or the same color code as I did on the first one. Now, I'm going to show you something with an old used cable. And a lot of times in the field, this is what you're going to run into is a used connector. And I've already stripped off the end. I've got all the parts I need for it. Except I can't find my white strain relief. So I'll just steal one from something else for now. So out in the field, I've got a used connector, and let's just say this got ripped out of the back of a speaker cabinet, and I need to repair it. I need to put it back together so that we have a working speaker cable once again. So I'm going to take the boot or the cap. I'm going to put that on first. I'm going to make sure that all of my wires are exactly the same length. And if you'll notice, my black is just a little too long. And that'll happen over wear and tear, stretching the cable as it goes through production in its life. So I'm going to go back and I'm going to trim that all off so that all the connectors are exactly the same length. And when I get to the other end, I'll show you why that's so important. So now that these are all the same length, I want to make sure I've got the same amount of copper showing on each of the stripped ends. And again, I'm going to line these up in the same configuration as the terminal block. I'm going to put the same angles that I did on that first connector so I can seat all four at once. And it's going to take some time and some practice to figure out exactly the right position to put everything so that you can do this all at once. But once you get it down, it'll become like clockwork doing it regularly. Now, because it's an old used connector, these terminals are going to be closed up. There's an extra strip of metal inside of each terminal that clamps down on the copper. So you want to make sure that you've not only backed off the individual Phillips screws for each terminal, so they're nice and open. But I also want to take a jeweler's screwdriver and cram it into that open hole and make sure that little piece of metal is bent back into its original position. And now I have a clear open hole for each of the conductors to go in. I'm going to look again for that fat groove, that fat dimple. That indicates number 1+. And I've got my black, my white, my yellow, and my orange all lined up. I'm going to seat the black first, yellow next. Little strand pulled off of the side of the white, so I have to start over. Black. Yellow. White. And orange. Once I've got them all started to seat, I can now roll it back up. And all four conductors are now seated inside of their respective terminals. And then I will tighten them all down. Now, one thing that I always keep in mind when I'm working in the shop is a lot of these connectors, when they go bad or they get broken, and a lot of times you'll find that after a long show, after a big festival, these go through a lot of punishment. And a lot of times you'll find that somebody's actually broken off a good portion of this end. At that point, I'm going to replace it with a brand new one. But in taking out the old broken piece, these little terminal screws and the little flange piece of metal, once they fall out, if you back off that terminal screw too far and the pieces all fall out and fall on the ground, it's really hard to find them. So every time I'm taking apart a broken one, I'll take those terminal screws and the little flange and metal, and I'll save them. I'll put them in a little bin and set them off to the side so I have a collection of them. For just that reason. If I just so happen to back off the screw too far and lose one while I'm sitting at the bench, I have a bin full of spare parts. So rather than taking the time to look around on the floor to find the piece, or let's say you're on stage in the middle of a show, you don't have time to go around looking for little bits and pieces, so it's better to have some spares sitting around. Anyway, that said, I go back to my boot that I put on first before I ever started to strip the wire. I select a white, because this is speaker cable, not power cable. I'm going to select the white strain relief. I'm going to line that up so it's in the correct position. Now, because this is a used one, I don't have that extra little flange piece of plastic to line it up. But I can see that my groove lines up with the groove of the terminal block. Now for my outer casing, I'll spin that around until it sits right in the groove. Slide it the rest of the way on. And now I have fixed the cable that had been yanked out in a hurry at a live show out of the speaker cabinet. And that should be good, right? Well, I need to test it. So there's a multitude of ways of testing it. Now, Whirlwind makes this lovely box. Let's go with the front camera there. That has a multitude of connectors it can test. NL4s on one side, NL8s on the other, even XLRs. They make another model that has either cons, and yeah, it's a wonderful, lovely box, but you have to have both ends of the cable at the tester. So Dave Rat over at Rat Sound produces a line of equipment, testing equipment, and other things under the name of Sound Tools. The last webinar I did, I used the XLR sniffer sender as a tester. He also makes one for NL4s. And if you'll notice, there are, on the sender, it sends the signal down all four lines, and on this sniffer, it has the receptacle with the four indicator lights. All four green means all good. There's a variety of configurations of those LEDs that will tell you which problem you might have. I'm sorry? Oh, yeah. Okay. Sorry, I'm getting director's notes again. So if you'll notice, there are indicators all the way around that'll tell you the LED indicators are notating a particular problem if they're not all four green. so let's test the cable I just fixed. I'm going to put the sniffer on one side. I'm going to go to the other side. Yeah. And put the sender. Okay, sender showing me a green LED. And oh, why, looky there. I've got troubles. Now, it can't be the end I just made, unless I really messed something up, but I'm pretty certain I did a very good job on that. So it's got to be the other end of the cable. So I'm going to open that up and take a look. And sure enough, well, there's actually a couple of problems. Let's go to the first of those two problems. I'm going to put this back together to show you the first of the two problems. And this problem will lend itself to almost every cable that you'll come across. If you'll notice, all the conductors are exposed. The jacket is no longer inside of the cable grip. So that cable grip is actually holding on to nothing. So that's the first of our problems. And the easiest solution for that on this cable and any cable that you're going to run into with that problem where you have exposed conductors outside of the cable grip, and I'll show you on a power cable later, open up the boot, the cap, make sure that your cable grip is open, and then, a couple of feet into the cable, I'm going to step on it. So holding it under my foot so it's all in one place. And let's get the long shot there for there. No, let's do the zoom for this. Yeah. I'm going to grab it with both hands and I'm going to pull the jacket up from my foot. So what I've done is on the tight shot now, I've stretched that and my feed is coming in and out again. Yeah, 1, 2. I've stretched the jacket back inside of the cable grip. The reason that problem happens is because people, when moving cables around, will just grab the connector itself and not think about the rest of the cable, and they'll pull it. And they'll stretch it across any multitude of things. And after a while, those inside conductors will stretch away from the jacket and will pull the jacket right out of the cable grip. So it's something to keep an eye out for on any of the cables that you're using. Speaker cables, power cables, even multi-cable, multi-conductor cable for microphone connectors and stuff like that. Anytime you see that the jacket has slipped out and is exposing the conductors inside of the jacket, the reason that's happened is because the jacket has stretched. Now, the other trouble we have with this, now that I've opened it up, you'll notice that I have 3 conductors that are connected to the terminals, but there's a 4th that's just flopping in the breeze. And the reason it was making intermittent connection, showing 4 perfectly fine green LEDs until I started wiggling this cable, is because it was just making contact with the terminal, but it was not seated. It was not seated inside of the terminal, and boy, this is driving me nuts. Yeah, 1, 2. Let's hope that works for me. Sorry, my ears are going in and out. At any rate, the reason that that's the problem is because this conductor was cut too short when making the cable in the first place. That's why it's very important when you begin to make the cable to make sure all 4 conductors are exactly the same length. If one's too short, no matter how well you've tightened it up, it's going to pull out of that terminal over a certain amount of time of use. So to fix it, I'm going to have to redo all 4 terminals. So I'm going to take it apart. I'm not going to go back through the process of putting it back together. I've already shown you how to do that. But to fix this problem, I'm going to expose as much as I can of the short lead. And I'm going to nip everything off to that exact length. Excuse me. Okay, so now I've nipped those all off to the same length. However, now I'm really short. I'm really short on what's exposed out of the jacket, so I'm going to strip some of that off. Being careful, of course, not to cut into the insulation of any of the individual conductors. I just want to strip away the jacket. That's a little tight, but it'll work. So at this point, I want to make sure that I've stripped off the wires exactly the same amount, just like I did making the other cables. And we go through the same process as we just did, putting the end back on. And like I said, remember, because this is a used connector, we've now closed up all of those terminals. So I want to take the terminal screws and open them up, and then grab a jeweler screwdriver and open up the little flanges of metal so I have a nice open terminal to put the wires back in. And then I can go through the process that we just explained. And put all this back together and then run another test. And since we've already covered that, I'm just going to set this off to the side. Now, Sound Tools makes a variety of testers. They make the XLR tester that I used in my first webinar. They also make this one, which is the NL4. They make one for an NL8, and they make one for a Cat5. So it's a versatile variety of test equipment that they make, and they are invaluable because I can put the end of the tester on cables that are already run. I don't have to have both ends at the tester. All right, really quickly, let's show you the NL8. The difference between the NL8 and the NL4 is, as it says in the label, one is for 8 wires, one is for 4 wires. The NL8 can run twice as many as the NL4. It has 8 individual terminals instead of just the 4, but it is primarily the same configuration as the NL4 in the layout. For the NL8, I'm going to be using 8 conductor, and it's probably too hard to see, but maybe if I strip this away, it'll make it easier to see. So here's my NL8, brand new out of the box. I have my cap, or my my hood or my cap, you'll notice that there's a little black insert that goes into that. And there's a reason for that wonderful little black piece of plastic, and that grabs onto the ends of the cable grip and squeezes them together. So it's a little more, there's a few more working parts, so to speak, than the NL4. But again, I want to make sure I have that cap on first. Very first thing I'm going to do is put that cap on so that I don't forget it. And then I'll go about stripping my wire. Again, I want to make sure that I've looked at the strain relief, the cable grip, and the terminal block to make sure of what length. I see. I want to make sure of the length, and I'm stripping the jacket back off so I have enough of the cable grip grabbing the jacket. So I can get about an 1.5 inches on an NL8. It's a little more wire than I need to make the terminal connections, but there's a reason for that much leeway. I'll show that to you in a second. All right. Thank you. All right. Using the using the Whirlwind color code, which you can download from whirlwind.com. They will show you that their common color code is for black, white, then red, green, brown, blue, orange, and yellow. Because basically the Whirlwind, along with several other companies, manufacturers, produce their cable in that configuration as it's being made in the factory. So with an NL8, we're going to follow the same basic practice, stripping off only as much copper as I need to fit inside of the terminal. But before I start stripping that off, I want to make sure that all of my conductors are exactly the same length for exactly the same reason as I showed you on that last repair. If any of these conductors are shorter, they're going to pull right out of the terminal, no matter how tightly I've got it tightened up with the terminal screw. Because they're too short, they're going to pull right out over the course of time. I want these to last forever, so I'm going to cut these all the same length. Now, given that this cable is 8 conductors, you'll notice that 7 of those conductors are all around the outside, and there is one going right down the center. That's the yellow. If I'm making a short cable, this is all fine, keeping them all the same length. But because this wire going down the center is going to stretch out less than the others will, that yellow cable over the course of time, or that yellow conductor, I should say, over the course of time, is going to become shorter than all the rest. So let's say, I'd say 50 feet or longer, I'm going to adapt how I would dress the conductors before I actually make the connection. So let's say that this is going to be a 50-foot long cable. Rather than having all the conductors at exactly the same length, I'm going to leave some extra length on that center cable, or on that center conductor, so that it has room to stretch. Or I should say that the rest of them have the room to stretch without making this one shorter than all the rest. So I'd already stripped it off the outside jacket to allow for the terminal block and the strain relief, the cable grip, and made sure that this was going to grab onto the jacket. However, I want to leave some extra length for that yellow, so I'm going to strip it off again, adding about a 1/2 inch. And the reason I'm doing that, and this will extend the longevity of these cables 50 feet or longer for a much longer time. So now I've added an extra 1/2 inch to everything. And the only reason I've done that is to allow myself to pull the yellow conductor to the side and trim the rest of the conductors so that now yellow has a little more stretching room. Only a 1/2 inch will do. Let's say if you're doing a 100-foot cable, I'd make that an inch extra length. But we'll go to the same configuration now on the seating of these terminals. There we go. Get rid of the excess slop hair, what we call wadding. The seating of these, I can't do the same cheat I did with the NL4s in that I can't prep all 8 of these to just slip in all at once. I'm afraid, with the NL8, you're going to have to do them at least a pair at a time, if not each individual at a time. So the NL8 is certainly more time consuming, but just prepare yourself for it so that you're ready to go. There is, however, the same basic idea of being able to tell which is terminal 1 plus off of those dimples on the outside of the terminal block. I'll show you that in just a second. All right. I've got my boot on. I want to make sure my cap is on the wire before I even start to think about the terminal block. But again, you'll have a fat dimple on one side of the terminal block. On the opposite side, you'll have a narrow one. The fat side, like the NL4, I'll go straight down, and well, let's explain this first. On the NL8, just like the NL4, they have embossed numbers indicating which is which. Now, I don't know if it was the original design or whatever that manufactured it this way, but the NL4, it was directly, that terminal directly over the fat dimple was number 1. Well, that's actually number 4 minus. Number 1 plus is just to the inside of that. It's a lot easier to see the embossed numbers on the NL8 than it is on the NL4. But you can take that as a reference point. It'll take some time and some practice to be able to identify as you go. But I'm going to start with number 1 plus. Make sure all of these strands are nice and tight as you can get them. So number 1 plus, which is black. Oh, I forgot to open up the terminals. Because with the brand new, straight out of the box, The terminal screws are in just a little bit. So you need to make sure you stop and open them all up. Same process though, basically as the NL4. So I'm going to start with 1 plus, and I'm going to go all the way to the end at 4 minus, which is going to be yellow. That way I'll have the pair of terminals that I can tighten up. So on the inside is black, which is 1 plus. On the outside is yellow, which is 4 minus, all the way at the end of the line of all 8. Then I'm going to go to number 1 minus, which is white, and then to number 2 plus, which is red. And I'm going to keep going around in pairs until I have tightened up each group of 2 wires. You're going to be starting with the minus of the last pair. So, and then going to the plus of the next pair. So I've done 4 minus, which is yellow, 1 plus, 1 minus, 2 plus, which is red. I'm going to go to 2 minus, which is green, and 3 plus, which is brown. So keep in mind, I'm doing these all a pair at a time. Okay, cool. I'm a bit over time, so I'm going to try and button this up as quick as I can to get to the power. 3 minus, which is blue, and finally 4 plus, which is orange. And again, I need to check after I've tightened these up to make sure I have no copper exposed at any terminal. And no little strands sticking out anywhere that would cause a short later. Now notice that yellow is sticking out quite a bit. It's okay. I want to have that extra length so it has, over the length of the cable, over the length of using the cable, it has a chance to stretch. So I'm just going to tuck it inside the rest of the wires and leave that slack there to be taken up over time when this cable gets stretched out. Cap is on first. I'm going to go to my strain relief. Now there is no wonderful little grooves or anything to show you directly that this is in the right position, the cable grip. The only reference you have is there's a little bump that you need to line up. There's a slot inside of the casing that will line up with those two. So that is the only reference point on the NL8 that you've got to make sure it's in the right position. And once you've got it in the right position, rotate this. There we go. Cool. All right, tighten it up. And there we have it. All right, and the same deal. I'm going to want to make sure that I test the cable after I've made both ends. Keep in mind what I showed you about the jacket slipping out and exposing wire. The same process can be used to repair that. Stretch the jacket back in, open up the cable grip, and then you can stretch the jacket back into the cable grip and tighten it back up. Okay, with time constraint as it is, I just want to touch base really quickly on the power connectors. Neutrix was nice enough to make a variety of power connectors as well, and you're going to run into these quite often on major company builds for live events and such. There are two different colors. There's a white and a blue. Power for each is only going to be 3 connections. Color codes for power is extremely important and cannot be deviated from. It is a universal language amongst electrical power that must be adhered to. In the United States, neutral is white, hot is black or red, or, well, for our case study in the cables that we're going to be working with, if it's just 3 conductors, it's either going to be black or it's going to be red. And then green is always ground. Now, that's in the United States. In Europe, blue is neutral. Yellow with a green stripe is going to be ground, and brown or black will be hot. It's important to know that because with all things electrical, making sure the neutral is in the correct position and the ground is in the correct position is absolutely essential to the safe operation of the equipment. Boy, it's warm in here today. Any rate, something I want to point out on the Powercon connectors. As you will see, there are 3 connectors per. Keep in mind that 2 of the terminals, the screws are in the same direction. 1 of the terminals is in the opposite direction. The one oddball, the one that's facing the opposite direction, is always neutral on the Powercon connectors. You're going to want to strip the wire much as you did the speaker cables, as far as just that much, just enough copper to go inside of the terminal. So neutral is the oddball, the terminal facing opposite direction of the other 2. Ground will always be right down the middle on the Powercon, and load, black or hot or red, will be on the opposite side of the neutral. They are indicated again with embossed labels on each of the connectors, but they're hard to see. Which is why I point out a fast way to find them is the 2 facing the same direction are going to be ground and hot. Ground will be in the middle. The oddball, the one facing the opposite direction, is always going to be neutral. Something else to keep in mind with the Powercons is the white receptacle, or the white end, I should say, is for going into the receptacle providing power. This would be the panel or the power supply that you're coming out of for panel or for power. The blue is what attaches to the piece of equipment, or the blue is giving power to something. The white is taking power from something. So keep that in mind. I want to just touch base really quick on this last connector, and then we'll go to Q&A. I'm sorry I didn't get much time to go over the power connectors, but let me show you this one real quick with just a common, ordinary Edison connector. again, here's the same trouble we were seeing. Yeah, there we go. The same trouble we were seeing with that speaker connector. See how the terminals are exposed inside of the jacket? It's the same fix. I'm going to loosen up the cable grip. Make sure that's nice and open. And then, well, it's not a long enough cable to be able to step on it, but I'm going to stretch that jacket back inside. So now I can look, and it's just only a little bit inside of the cable grip, so I'm going to go another round of stretching to make sure that it's in. And it is. So now I can tighten it back up, and no more conductors are exposed. The only other fix for that is to actually disconnect the whole end and restrip the cables. And considering the way that happens is because people just grab the cable by the end of the connector and pull it across the stage or across the, just pulling the cable by the end of the connector is what will stretch out the inside conductors away from the jacket. And that's how you end up with it showing exposed conductors. So we just sort of reversing the process. Last thing I want to show you is a large power connector. Now this is the same when it comes to, in this case I have a 5 conductor power cable, which is what is known as a 3-phase connector. It has 3 hot lines, 1 neutral line, and 1 ground line. And I already know, because reading the instructions on the box, I need 1.5 inches of jacket stripped away. And the reason I'm making a point of this is because you will find this flaw in many connectors, or at least I do all the time, because people don't follow those directions. And I promise I will be as quick as I can with this. But the same principle applies. I'm just stripping away the jacket without cutting into the insulation of the individual conductors. In power cable, you will find twine, or what we call wadding, between the individual conductors. I want to pull all those away and cut them off so that they have, so that they're out of the way of all of my connections. And I got one more down the middle. So with those out of the way, I'm ready to start making the contacts. So along with all the rest of them, I'm going to, before I suppose I sort of jumped the gun by stripping off the ends and not putting the cap on first. But as long as I'm putting that cap on before I've made the connections, I'm in good shape. But generally speaking, before I even make those, even strip off that wire, I'm going to put this cap on. Now, here is the most important part. On the directions of the box, it says I need to cut off, I need to strip away 11/16 of the individual conductor, the individual insulation on each conductor. 11/16 is almost 3/4 of an inch. So actually, I want to strip off that much copper on each conductor. I want to show that much copper. Now, a lot of connectors that I run into that have failed on stage, I'll open them up and I'll find that somebody stripped off only that much, like a 1/4 inch or so. And the reason that it's important that you have so much copper exposed is it needs to go to both sides of the clamp inside of that terminal block. If you're only sticking that much, that little 1/4 inch of wire, it's only being grabbed by one side of the clamp and it'll never hold. So make sure to follow the directions wherever you see it. And with that, I'm going to just tighten this up, and as I'm putting it all together, I want to make sure all of my strands are twisted up nice and tight before I connect it to the terminal block. I want to make sure that all of my ends are the same length, which actually they are, which is nice. A little bit of trim. The last most important thing about all of these connectors, it doesn't matter if it's a 3-pin connector or a 4-pin or a 5-pin. The main thing you want to make sure of is that ground and neutral are in the correct position on the plugs. So read the directions, look at each one, and make sure that you're connecting the correct neutral and ground. As long as what we have labeled on each of these X, Y, and Z are the same color on each end of the cable, you can rest assured that the connection is going to be verified or verifiable on both ends. There's one difference with this one, which is the ground I need to make shorter. But as it's indicated on the box, on the directions, and each of these will have directions on them. I'm going to cut short that one at the specific length that they recommend on the box, which is 1 inch entirely with a 11/16. Or is it 11/16? I think it's like a little shorter than that. 7/16. So you'll notice that the ground wire is a little shorter than all the rest, and that the amount of copper showing is a little bit less. So I'm ready to seat that. It will fall in. It'll fall into the correct. Well, fancy that! I forgot to bring a flat blade screwdriver. Well, I'm going to leave it there for now. We'll come back to this another time, but because I can't seat the ground, but I can show you the rest. All right. So with each of these terminals, I want to make sure that the insulation is all the way in next to the terminal with no copper showing. White being neutral, they're nice enough on this to indicate with a chrome screw. And the hots, X, Y, and Z, are indicated with brass. At any rate, neutral on this particular model, and you'll find the model number on each of these on the sticker. This is manufactured by Hubble. This is an HBL2811BK is the model number. The neutral will always be in that particular flanged terminal. But another model made by the same manufacturer may have the neutral in a different position. So you need to read up on that and make sure that you're connecting neutral and ground to the correct terminals. With that said, I should get over to Q&A so we can wrap this up because I've gone way over time. But I hope I've at least made some reasonable sense of some of the common connections that we have to deal with. And with that, I will take it back to you guys and open up the floor for questions.
All right, thank you so much, Fedj. We do have a few questions that have come in. The first one is asking, my church has NL2 connections for TOA monitors, but I have never seen it in professional use. How professional or good are NL2 connectors, and are they still used?
NL2s, few and far between that I've seen them. I see them more with home stereo equipment and stuff like that. But they are still used. And to tell you the truth, they're a bit of a pain. I would have bought one. I would have brought one down here today, but few and far between when you see them. More often than not, in professional grade gear, you're going to run into a setup with an NL4 connector that's only using two connectors. It's only using two terminals. Take, for example, a sub cabinet will only need the connection for one speaker. Generally speaking, most of them are set up that way. However, manufacturer to manufacturer, it may be terminal 1 plus and minus, or it may be terminal 2 plus and minus that are needed. So you need to check on the labels and the manufacturer to make sure of which one. Few and far between do I see the NL2 connectors used anymore.
All right, next question is asking, is it advisable to tin the copper with solder?
Actually not. There's some argument there, but the main reason I don't recommend tinning, and this is my recommendation. Others may say, yes, absolutely tin them. But the reason I don't, I want the, excuse me, I want that connection to be as flexible inside of the clamp as I can so it can get a tighter fit, so to speak. I want to make sure that terminal is as tight as I can make it, so they don't have to worry about the wire slipping out. When I tin it, it basically turns a strand flexible wire into a solid core wire. And I can tighten it to a certain point, but over time, that solid piece of wire, now that it's soldered, basically loosens up inside of the terminal. So I recommend no tin, especially with a crimped connector or a clamped connector. You want to make sure that you leave the solder out of it and just use the strand copper all by itself.
Okay, next question. When you're stretching the cover to go over the wires, is there a good way to check the cover to make sure it won't tear somewhere else?
Good point. Like I said, generally the main reason that happens in the first place is because somebody was just pulling on the end, and dragging it everywhere. And anywhere you can, anywhere you're working and remember, and tell everybody else, that you're working with, please don't grab just the connector and pull the wire across. Grab the cable itself. But because that is the most common occurrence for the jacket to slip away from the cable grip, the odds are that the outer jacket has already been compressed, and you're not going to be doing any more damage. But it is always a good practice whenever you're running cables after you've tested everything, or when you're prepping the cables in the first place. To inspect each one, go all the way down the whole length, and make sure there are no tears. And if there is a tear in the jacket, there is a simple way to repair it, and that's shrink tubing. But it's a special kind of shrink tube that you want to use when repairing a tear in a jacket. I actually have a tear down here that I wanted to get to and use my new heat gun and show you how to use it all, but I ran out of time. The special shrink tube to use for torn jackets, though, is a glue-lined heat shrink. It has glue on the inside of the heat shrink. So when you put it in position, you cut off the length that you need to cover up the entire tear. Put it in position over the tear in the jacket. And when you heat it up, it activates the glue inside of the heat shrink. So once it shrinks down around the cable itself, it's actually glued in position and won't slip as time goes by.
Okay, we have a few more questions. What is the best way to solder NL4 or NL8 connectors, or should they not be soldered at all?
There's only one time I would ever solder an NL4 connector, and that is if it is the original NL4. And talk to some folks who've been around for a while. I'm old enough to remember when the original NL4 came out, and they used hex set screws, and you had to put a little copper sleeve around each of the strip conductors, and it was a pain, and they always came apart. And the only solution that any of us could come up with was solder it. But I tell you what, if you ever open up an NL4 and find that it's an old NL4 and somebody has soldered it, my best advice, go buy a new NL4, clip off the old NL4 with the soldered connections, and remake the connections with a brand new one. The real trouble with making a soldered connection on any of these is the fact that it is now in stone that the connections in order are made on that particular connector, and it can't be repaired. Especially if you're out in the field somewhere and you don't have access to a soldering iron, and you don't have this and you don't have that. The most wonderful thing about the NL4 and the NL8, all you need is a Phillips screwdriver and a stripper, maybe a knife. But I would not recommend soldering any of these because of it makes a good connection, but it's almost impossible to repair.
Okay, next question is asking, what temperature is the best to solder at for speaker wiring?
Excuse me. Sorry, I've had a frog in my throat all day. Like I said, I don't recommend soldering, but it's not, the temperature is not dependent upon the wire itself as much as it is the solder itself. So whatever solder you have, go to the manufacturer of that solder and find out the melting temperature. Generally speaking, it's going to be about between 315, 375, sometimes more. Uh, Generally, I would go with the lower temperature solder to make any of the connections. And about the only time I ever do solder connections for any of the speakers, speaker terminals, is if I'm doing like a panel connection. But as far as cables, I highly recommend staying away from soldering those. I highly recommend using the terminal screw connections because you can repair it as time goes on.
All right, next question. How can you avoid the dreaded dry joints?
The dreaded dry joints. I am thinking you mean in terms of solder connection and cold solder joints. I'm not sure if that's exactly what you mean, but if that is what you're speaking of, and I hope it is, my best advice for making any solder connection and avoiding cold solder joints, as we call them, tin your ends. If you're connecting a wire to a terminal, make sure you tin the terminal. So put a little solder on the terminal itself where you're connecting the wire. Tin the end of the wire. So make sure you've got a good flow of solder on the conductor end itself. And then apply just a little bit of solder to your soldering iron when you're connecting the two together. But heat up both elements, both the terminal and the conductor, as you're making any solder connection.
Okay, next question. Do you prefer the metal or plastic NL4 or 8?
The plastic is more common. It's certainly a lot cheaper. The metal is, as you would imagine, more versatile, more expensive, but holds up a lot longer over the course of time. Few and far between, though, have I seen them in touring rock and roll rigs. I've seen them a lot more in specialty AV setups. Basically, the plastic connectors are just as efficient and make just as good a connection as the metal. And as long as you're careful and have competent people using the equipment, they should last years. But the metal is always better, but it is more expensive. And I can't say it's functionally any better than the plastic. It just lasts longer.
Okay, we have another question. Could you please comment on the major considerations between XLA audio cables and XLR DMX cables?
Well, that's kind of jumping back to our first seminar, webinar, but no, happy to. XLR cables that are made strictly for microphones are basically audio analog cables. They're not designed for digital. DMX cables or AES cables are designed specifically for digital information. And I didn't know this until recently. There is an actual cadence of the twist inside of the cable, the plus and the minus conductors inside of the shield in digital cable that is calculated the amount of wraps, the amount of twists per inch or per foot is gauged specifically to carry digital information. Now, you can use digital cables to carry analog audio signal. But if you use audio cables to carry digital signals, you're going to run into troubles. You're going to run into dropouts. You're going to have corrupted information, possibly. If it's a very short run, you can use XLR cables, just straight XLR cable for a very short length, but it's always advisable. Anywhere you're running data, you want to make sure you have digital cable. There is a specific design to them that carries digital information better than any analog cable would. Keep in mind, analog cable is not designed to carry data.
All right, it looks like that was the last question that came in. So thank you so much, Fedj and Sean, for your assistance with this. This is now the second session that they have done with us. So if you missed the first one, you can find that out on our JBL YouTube channel. And if you want to take a look at any of the upcoming sessions, our full calendar is available on pro.harman.com. And I want to thank all of you for attending today and spending your time with us. Thanks again, Fedj. We really appreciate you doing this.
Certainly. My pleasure.
All right. Have a great day, everybody.
Thank you.
Bye.